Now starting, all attendees are in listen-only mode.
Hi everybody, thank you for joining the first webinar of our Technology Week. I'm very excited to hear more about space cooling today from our two speakers, Ulysses and Richard, which I will introduce in a second. I want to remind all attendees that this webinar is primarily designed for the participants of the Efficiency for Access Design Challenge, an initiative from the Efficiency for Access Coalition delivered in partnership with Engineers Without Borders UK. Throughout the whole webinar, do feel free to ask questions in the question box that you should be able to see in the GoToMeeting window. And I'd like to flag that this webinar will be recorded and made available on our website for all Efficiency for Access Design Challenge participants. So today, as the first day of our Technology Week, we will hear from two people from the space cooling sector. So first, Ulysses, a mechanical engineer working at Solaris Offgrid, a company headquartered in Valencia in Spain. So Ulysses is an industrial designer from Argentina. He's been working at Solaris for the last few years, developing new products such as lamps, solar home systems, solar panels, and other products to enable people to have energy access in off-grid scenarios through pay-as-you-go method. And he will say more about his company himself. And Richard is a director of the PSH Group, which is a leading design and manufacturing company headquartered in Hong Kong with its own manufacturing facilities in China and offices in London. So the PSH Group works with many leading brands and companies in the telecom sector, consumer electronics, as well as government organizations. As part of the PSH Group, Renewit designs and manufactures a range of solar power and lighting solutions that have been developed to improve people's life in areas of the world with little or no access to electricity. I will leave now the floor to Ulysses, who will start talking more about space cooling.
Hi everyone, I hope you hear me well. I'm really excited to be here and show or explain what I have learned the past years. So I will start talking about our market and design insights coming from our operating branch in Solaris, Tanzania. This is where we get our field experience and where we are in charge of last mile distribution in Lake Victoria region. So if we move to the slide that you see now is the topics that we're going to cover in this presentation. And if we move 2 slides forward, okay, so the Solaris Tanzania portfolio only has 20% of their users that plug fan or cooling appliances, but our systems deployed in the field actually are 70% who can actually have the capacity to plug cooling appliances or most commonly DC fans. But what I see from our distribution and other distributors is that normally fans or cooling appliances are not included in the SHS package, meaning that solar home systems are normally sold with lamps, batteries to run, and that would be all other appliances, and then sold externally, and most likely are sold by local shops which do not include a pay-as-you-go offer. So what is pay-as-you-go? Pay-as-you-go, for those ones who may not know, is a mobile payment system where people can pay for leased products while they use them. That's why the name. And this is a great gateway for those people who want to acquire a product but cannot pay the upfront in like the total amount upfront. So mobile payments and pay-as-you-go management systems allow distributors to sell products and finance people in a microcredit. So in the long term, let's say 2 years or 3 years, while people use these products, the product is paid back and the ownership is obtained. So moving forward to the next slide. Yeah. So currently the biggest, cooling appliances are offered at an affordable price. It ranges between $5 to $35. 5 for those USB small fans and 35 for more bigger fans with better features, let's say. So we have also seen, besides from what you see in the picture, we have seen also ceiling fans being sold in the field. But an insight that I can give you in this is that distributors try to avoid installing ceiling fans because it requires an extra installation performed by the electrician. This can add costs, and that's why distributors prefer just to sell a closed box or a package which is actually plug and play. Plug and play meaning that you plug your system and you can run it directly, quite easy and quite straightforward. So moving to the next slide. Yeah. Okay, so which are the problems that I've seen and discovered in the field? Well, currently the biggest drawback of cooling appliances, as most other products in the market, except LED lighting, which is actually quite efficient at the moment, is efficiency. So the amount of energy that we need to run this appliance in an efficient way and actually obtain the results that we want. So it's my personal point of view that final users also most times pay for some features that they don't really use. And when we are talking about really cheap products or efficient products, having, for example, how would you say, like a flashy enclosure or something that it's quite expensive to manufacture without any additional function, those clients tend to pay that cost, and it doesn't add anything to their product. An example I'd like to give, for example, is that if manufacturers save money in enclosures, let's say, they could potentially add batteries or different features that could enable different options for the users. I would say that in the fan or in the cooling market, there's a lack of innovation because currently manufacturers are only rebranding white branded products. So mostly buying Asian products or Indian, which are white branded, and then they resell it under their own brand and logo. Moving forward. Yeah. Okay, so how does cooling relates with the sustainable development goals? Well, from my point of view, fan or cooling is actually a comfort asset. So it's not directly linked with the sustainable development goals, but I could argument that building a solar powered lifestyle, meaning that you run your appliances through solar energy, it's helping goal number 7, which is affordable and clean energy. So if everyone would be powering their appliances, then we will all be contributing to goal number 7. Another goal, which I think that it's quite interesting to point, is goal number 4, which is quality education. By this, I'd like to point probably one interesting user case. So it's schools. And when it comes to cooling, these appliances could have a great job inside schools, when actually the moment we only see reading gadgets like e-readers or lights to help kids to study in night, but there's a lack of innovation also in this sector. I would say like helping schools to be cooled down, that will help a lot kids to study in better conditions. Moving forward. Yes, okay. So which is the market direction? Last year, we have accounted that more than 1 million solar home systems have been sold, and this figure tends to increase 70% annually. And from what we see in different conventions and we talk with our competitors, is that solar home systems are going to be available or are going to be featured in a way that you can share energy in a mini grid or P2P way. So you will be able to sell energy to your neighbors, or he will be able to sell energy to you. This, in theory, allows you to save costs in energy storage appliances or energy storage hardware, actually, so decreasing the size of batteries. However, this theory or this system has not been fully proven, I would say. And yeah, there will be education needed for users, so to people understand what energy trade means, because already pay-as-you-go is causing confusion in people. So adding extra ways or different things to your offer may make it more complex and could generate frustration to users. Another tendency, let's say, that I see is modularity. So manufacturers have discovered, I would say in a bad way, because they had to pay the cost, that products need to be modular or upscalable. It's logical that users, when they cover their needs and they have paid their system, they will try to get more appliances, power different gadgets. So to increase the capacity of the system will be logical to do. So what manufacturers like BioLite or SolarWorks are doing at the moment is to build modular solar home systems, also like we do. And this allows customers not to replace the solar home system enclosure or the whole solar home system main unit when they have to upscale. This is a big issue also because when products tend to fail, most likely because the batteries fail, if you have an enclosed battery and your battery is located inside the solar home system or the charge controller, you will need actually to discard everything and replace the whole unit. And this is a cost that most distributors have not foreseen, and now they are paying, which is quite annoying for them and making their operations more expensive than expected. Another trend that I see also is that systems, I'd say, they're going to upscale, but also they're growing. So appliances will be more power hungry, and they will have to deliver more energy. So if we move to our next slide, so I would say the past lessons or what we have learned from other competitors' mistakes and our mistakes is that manufacturers need to understand properly the lifespan of their products that they deploy in the field. Meaning that when you sell a product, you have to know exactly how long the lifespan of your battery is going to be, and when this battery is not going to meet your client's expectations, because batteries tend to age quite fast. And if a state of health of a battery reaches 70%, let's say, then you won't be meeting your client expectations anymore. So what you need to do this, you need to do an accurate follow-up of your listed products. This is done by a lot of companies through GSM or some kind of wireless monitoring. Some others go place by place and gather data like surveys. And there are many types of ways where you can actually have an accurate follow-up of your products. Then I would say that there's an e-waste problem coming up. Last year, there were 2.5 million kilograms of e-waste generated from solar home systems only. And if we plan to design new products, we need to make sure that our design is going to be easy to refurbish locally, that materials can be recovered, and that, yeah, basically they can re-enter the cycle. Another past lesson is that distributors need to understand how their clients behave, because distributors want to sell and sell, but we need to understand that they have an economic limitation, and if they invest one time, that's going to be probably the only time they may invest. And if the product fails, let's say, the frustration of this user will be quite high. Okay, let's go next. So I'm going to go here quite fast. This is normally what distributors or the whole market shares or distributes the cost. So I would say it's 50-50, 50 manufacturers, 50 distributors. And inside manufacturers, you have what actually requires to manufacture and deliver the product, and it's going to have most likely a 25% of turnover. It could go lower because some startups or some companies which are not actually settled yet, they will make their margin lower. And then we have the 50% from distributors who have to pay customs, who have to pay operation, after sales, and other things. Moving forward. Yep. Next. Okay, so for space cooling, I'll say there are two different user needs. What I've seen is that there is indoor and outdoor use. So for indoor, the need is an insulated shed with active cooling to adjust room temperature at a comfortable point. This will be most likely households, different shops, which are actually indoor use. And then there's also the outdoor use, which I'm going to show you a picture later. And this need, I will describe it as an efficient way to obtain much more airflow as possible to directly decrease the body temperature. So here, as opposites, as indoor, we will try to decrease body temperature and not the room temperature. Forward, yeah. So how should this product look like? Well, first of all, I would say if you're gonna innovate in this, please do not make your product look unfamiliar, because I'd say sub-Saharan culture tends to be skeptical if your product looks like a toy or looks quite different to what they're used to see. And because they have never seen it functioning before, they will be, you know, saying, I don't know if this is actually going to cover my needs, and there's a great potential that your product is going to fail. However, if you're going to pitch your product locally and show how it works, and your innovation is performing as expected, then you probably don't need to be worried about this. Another point is what I call status builders. And it's a big thing in African culture where people take a lot of care about their status, and appliances or solar home systems are actually quite related to status, and people wanna, you know, they take care about how the product looks, and if it has some sort of status builder characteristics where they can feel themselves a bit better in this pyramid, let's say. And as I mentioned before, also white branding. If you're gonna sell your product to distributors, this is a great feature because most distributors want to have their own corporate identity on their products to, you know, to make their offer more solid and yeah, be also related to what they do in their marketing campaigns. Okay, next slide. So which practices do we have here in Solaris to make our products be reliable for our distributors and have a long lifespan for our final users? Well, first of all, we try to make our products unhackable. So we're talking about here electronic products, and as soon as people tamper your product, you're not going to be sure what happened, and it's a chaos when it comes to after sales service, because you never know if someone has tampered or it actually failed, like from a short circuit. Also, as I mentioned before, modular, it's going to be more popular every day, And when it comes to energy storage, mostly it's a killer feature because it allows people to invest little by little and not having to make big investments from the beginning. Another point I would say is minimal enclosing. So when you make enclosures, when you are actually designing your product, make sure that your product is as simple as possible and you're going to be spending as less as possible in a reliable and solid enclosure which won't or which doesn't have any flashy or different details that are going to make your setup cost or your unit price really expensive. Prepare also for local refurbish and recycle. We don't want to have a lot of e-waste in the future and to be responsible for that, because actually what distributors should be doing is responsible disposing by separating the different materials. Provide education and graphic descriptions. So take into account that people may not know how to read and they may not follow your user guide. So please provide drawings. And some people also provide audio feedback where they can learn how to use it, and expect that everyone is going to use your product, even kids. And if you advertise it in the user manual, most likely no one is going to read it. So be inclusive, and that's a great example that we learned from Pico products like the lanterns, where kids can use them, old people can use them. It's quite inclusive. Next slide. Okay, I'm gonna go fast here because I actually don't see that much of success when this product has to be portable. Why? Because culturally, sub-Saharan people have a high tolerance to heat, and carrying a portable battery-powered device may not be, or actually I can be wrong, but from what I see, may not be a killer feature when it comes to sale. However, if we move to the next slide, there may be a potential when it comes to income generation. Why? Because, and this is the example that I wanted to mention here, we see a tuk-tuk. It's like a motorcycle and it has a fan in the inside. We can consider this as portable or not, but what I wanted to point is that it may be a technology that it's used as a service differentiator. So if you have this appliance in your tuk-tuk, let's say, and it's powered by your motorcycle battery, then yes, it may be a potential sell, and it could also provide you indirect marketing, because all those people who jump on the tuk-tuk will be exposed to your logo, to your brand, and it's an interesting case to analyze also. Okay, if we move forward, I think we are ready. Just wanted to say, from Rustical to Moonshine, empathize with your users. Local experience is the biggest step forward towards positive energy access design. Please feel or try to feel what your users are actually doing, their emotions, and this will make you understand really what do they need. Because from a Western point of view, actually, it's a bit difficult to picture. Thank you, everyone, and I give you back with the presenter.
Thank you very much, Ulysses. Very insightful. We're now going to move to Richard's presentation. Keep asking questions throughout the webinar, and we will tackle all of them at the end during the Q&A session. Thank you, Richard. The floor is yours.
Thank you, Theo, and thank you, Ulysses, for that. My name is Richard Atwal. I'm a director of the PSH Group. So we're a manufacturer of off-grid solar products. So we're an agnostic manufacturer, so we'll manufacture for any brand or any company that wants to distribute and sell off-grid solar product. Most of our manufacturing is exclusively to the clients, so it may be a design exclusively for them, or features that are exclusive to them, and we have a range of clients across the continent of Africa. So regarding fans, Ulysses covered most of this area. They're of great benefit to the consumer. We have sold some current fans off the shelf, and they're very well received, but with several issues. the benefits, better health, better living conditions. There's a lot of health benefits, reduced risk of mortality in heat waves, and better productivity for people working. And it also, as the world's heating up, is allowing humanity to live in areas that are otherwise going to be very difficult to live in the future. In a first world, if you think of without air conditioning, would people really live in Dubai or California even? The market is huge. There's 800 million people living approximately completely off grid, and that number growing as population growth is outstripping electricity supply. And there's a further billion plus people live without good quality electricity provision. So maybe we're living with a generator, maybe living with a connection to the grid that's very intermittent. But more and more we need to make efficient appliances for them to use with this low-grade electricity. Next slide. So the aim of this challenge is design a fan for some of the lowest income homes on the planet. So price is an issue. Ulysses touched on it. You've got to be very careful about when you go through the design process that we don't add features or materials that end up making the fan expensive. It needs to be as energy efficient as possible to work with the smallest DC power supply. And there's many reasons for this. Although the cost of solar is falling, it's still expensive for the vast majority of people who live off grid. And with features like pay-as-you-go, there's more and more access, but still you can indebt a family for $200 for a reasonably small solar home system, which is a big commitment for a family. So the cost of the fan is not just the unit cost of the standalone fan, it's also to think of the associated cost of the power supply. So the more efficient the fan you make, the smaller home system can be given with it to work here. It's a mass market challenge, so it needs to appeal to a wide range of customers. So how are we going to design the next generation of fan? The graphic at the bottom there shows you that really over 100 years, the fan hasn't changed at all. Dyson came along and reinvented it for really an aesthetic look of how it's going to look rather than how efficient it necessarily was going to be. And part of this design challenge is what's the DC fan going to be going forward, working off DC power. Most importantly, the fan has to be hard working and hard wearing. Fans generally have a poor reputation. Particularly DC fans have a poor reputation where they break down quite easily. They don't give a good airflow. So customers have got quite a negative feel towards fans at the moment. Next slide. So who are we? As I said, we're a manufacturer of off-grid products. We have our own factory, so we do in-house development. We have plastic injection machines, PCBA machines, and we manufacture for a range of customers and brands across the off-grid space. But most importantly is to think about from a manufacturing perspective is we don't want to work in too many different materials. So for example, it's all very nice to offer, say, a shiny aluminium button, but we'd have to go and outsource that component somewhere else because we don't have metal machines in-house. And most manufacturers are like that. They tend to be specialists in certain areas. So for us, it's plastic injection and with the PCBA electronic boards. But if we wanted to do something in metal, we'd have to outsource that, which would add extra costs sometimes to product. Next slide. So we follow quite steady design process that most any of you in the design industry would be aware of, and it's quite self-explanatory. Next slide. So the customers, our customers are the distributors. They're off-grid solar companies, they're electronics distributors, they're telecoms companies, they're farming cooperatives, they're international brands. They will go out and sell to the end consumer, often with their brand on the product. And for us, it's an important definition. We're not going to, the product, we're not going to make ourselves and then design and then sell to the end consumer. We're going to sell to companies that are going to sell to the end consumer. So we have to support them with the marketing. So Ulysses made a very, very good point earlier. If we make it too much of a design that's unique or difficult to explain, it will be hard for these companies to sell the product. Next slide. So the customer's current issues with the product is quality and performance against price. How can a consumer tell a good fan? You can't tell if a fan's going to be good when it's in the box. And this causes a lot of sort of cheap product to come onto the market that lets people down. The example on the right there is you've got two images, one above and one below. One above is a cheap generic product bought in a marketplace. The one below has gone through an accreditation program to qualify that it's a good quality product. But actually, as a consumer, they have no way of knowing this. The other thing to consider about why the fan has got to be good and why off-grid companies aren't really selling fans at the moment, in a 50-watt home system, the fan will actually be one of the cheaper main components. The PV will probably be more expensive, the battery will definitely be more expensive, potentially even the rest of the accessories, the television will be more expensive. If the fan breaks, the customer will return the whole product to the distributor. So the fan has to be of good quality, otherwise none of the distributors will take it on and sell it because they don't want to drag down their whole system because of one poor component. So at the moment, many fans are just AC fans where they've just replaced the power board with a DC power board. Many are toy-like in look, the color, the plastic quality, and so on. And ultimately, we're looking for 3 solutions in one. We want to have a fan that can be a standing fan, a desk fan, and a wall fan, and potentially a ceiling fan. But all 3 of them can be from the same head. So, for example, if we designed the fan and the casing and the electronics in one block, the actual legs for standing or the legs for a desk fan or the connector to a wall can be a separate component that can go on. And for this, we can drive volume then. That means we only have to tool and develop one actual fan head, and it can be used in 3 or 4 different ways, which if we're going to drive down the cost of this product, one of the main ways of doing this is through the ability to use the same product across a range of consumer needs, because then we'll increase the volume. Next slide. So when it comes to design for manufacturing, I've covered most of these. I think manufacturing cost is a key driver. Keep to low cost materials. As I said, it's nice to have aluminium buttons and switches, but it will drive up the cost. Adaptable product, so the same product could be a stand fan, a table fan, and a wall fan. Yeah, the ceiling fan is much overlooked, partly because of the reasons Ulysses mentioned about people don't want to install it, but culturally it's very, very accepted, particularly in West Africa. So, for example, we're doing a product for a company at the moment where they want 3 ceiling fans with every box because people live in multiple rooms. They may want a fan in the kitchen room, they may want a fan in the bedroom and a fan in the living room. And actually their engineers install their solar home system and then install the ceiling fans as well. So there is an opportunity for ceiling fans, but it's got to be able to be installed and it's got to be plug and play safe. Yeah. So one of the problems with ceiling fans is they can be a little bit dangerous if people don't assemble them correctly. Next slide. So when I was thinking about this webinar, I was thinking about what kind of questions as a manufacturer are we going to get asked from our customers, and also what questions will we have as a manufacturer to designers or developers of a product. So obviously the leading questions from our customers are, for example, how much is it going to cost? What's the warranty? Can it be easily fixed, and can we supply spare parts? Now that's a double-edged question in a way, because we want to make it to the products hardware and long lasting, and really we don't want the ability to people to easily take the product apart, because nature is that people will try and take the motor out, they will use it for something else, or try and use it for something else, they will end up damaging the product. But via V, we need to be able to fix the product if it breaks on in country. Can it have its own battery? So there is again the combination. If we design the head part of the fan, it can have a fourth stand that's attached to it, which also contains its own battery to power it. And again, this is because people want to have more than one fan. They want to put fans in rooms that maybe are away from the main solar box. So this is something to be thought about. If we do this, can the fan be connected directly to a solar panel to be charged? I mentioned about running more than one fan from our solar kit. Can it work on pay-as-you-go, which it can do, because the pay-as-you-go can come from the main solar box, but also it's possible to have a handshake connector so that it can only work with that solar box, which is something to consider about, and Ulysses will have a little bit more information about that than me. From a manufacturer side, that's us as the factory, when we're making this for our customers, is we like to consider how many tools are we going to need to design and make, because that directly affects the cost. Material makeup, so plastic v metal. Is it easy to assemble on our production line? How many separate PCBA boards are we going to require? The less, the better. Will it pass drop testing, water ingress? We will need to do testing on the product because at some point it will need to be certified. So these things are important. Is there ability to flat pack it? One of the big issues with fans at the moment is the volume they take up when we ship them, which makes them very expensive to ship. To give you an idea, we can get about 3,000 30-watt solar home systems in a container. If we include a fan, that drops down to about 1,200. So, which puts the shipping cost up a lot. So is the ability to make it slightly flat pack, that it can be assembled with simple instructions when you unpack it. And obviously leverage on existing technologies, for example, brushless motors and so on. We've got to be very careful about thinking of designing something that we have to then go out and make ourselves, like a brushless motor, because that would incur, one, a lot of cost, and secondly, the timeline to market will be very long. Next slide. Oh, that's us. That's me. Done. I look forward to your questions.
Thank you very much, Richard, for your presentation. To all the audience, we're now gonna move to the Q&A session. So do feel free to ask questions now. Any question that comes to your mind, use the opportunity to have Ulysses and Richard here to answer them. We're going to start with a question from someone, I can't see the name, sorry. So the question is, and it's because you mentioned it at the beginning, Ulysses, how can we address the issue of high initial cost of a solar home system when it comes to rural schools? And that's because, Ulysses, you mentioned space cooling in schools. So I don't know if one of you two wants to take that question.
Well, I would say that prices would not decrease unless the technology gets cheaper. So there's no magic there. You can make a good design. Solar panels may stay the same price if they don't drop. Batteries will cost the same. When it comes to schools, particularly we don't know that because it's a different market. But when it comes to schools, it's important to get funding from NGOs, government, or other organizations which are actually willing to help in this type of goal, let's say the sustainable development goal.
Yeah, I mean, I think, again, a product being available for domestic retail or consumer retail is one point, and the price, that's very price sensitive. For schools and institutions, so particularly if we do powering health clinics, for example, a fan is pretty much the number one or number two item they want in a health clinic or a hospital. There are other funding streams for that. It's not necessarily, it's not going to be a consumer purchase. So although price is still an issue, it's not as sensitive to that in those markets.
Thank you very much. Second question that comes actually from me, so do feel free to ask question, audience. Would be interesting, so you both mentioned it, I think you both touch base quickly on safety and the importance of it for space cooling in particular. And just like when it comes to cooking, you can burn yourself. Well, fan blades can be quite dangerous. It would be interesting to hear you talk more about that issue, specifically for fans.
Yeah, I mean, I think the two areas are for a desk fan or wall fan or ceiling fan is that you need to make sure that children can't get their fingers in through the gaps to touch the fan directly. There is actually guidance for European and European legislation about the width of the gaps in the bars of the case that covers a fan to stop that happening, which you can easily get online. And then for ceiling fans is about we have to think on the board about and on the motor of putting automatic cutoff. So the moment it meets resistance, it cuts the motor. It cuts the power to the motor. That's a combination of an automatic cutoff switch that gets put onto the PCBA board, and the moment resistance is felt against the motor, it cuts the power to the ceiling fan, which is something we have to consider. So, for example, if somebody raises their arms into the air and touches the fan will cut off straight away. If somebody lifts a child up, they're not going to get their hair tangled into the ceiling fan. It will cut out straight away, which is something we should consider. And hence the main reason ceiling fans are difficult to sell at the moment.
I'd like to add, actually, with a question back. So, because here we're dealing with students and we all want to innovate, and I guess we all have really fresh ideas, I would say, how hard can they push innovation to solve this issue? We have just seen a picture from Richard, Dyson fan, which actually through innovation, they have solved this issue. So actually, there we can respect rules if we're going to use blades, but if we are actually trying to solve this issue through innovation, first I would say, why not think some brainstorming and think about, even using DC fans for computers. They are good, they have a high performance, and if you stick your finger inside, nothing is going to happen. It's not that strong to cut your finger. So, I personally would go back to the principle that compressing and accelerating air in a way, it's going to make it cooler. So from the principle, you can just go on and see if you're going to use blades or not, whatever. I think innovation is, starting to deal from the problem in the first stage, and why or why not think about blades.
Yeah, I mean, exactly as Ulysses says, your role as the innovators of this is to shoot for the stars, and to come up with the best of everything you can. And then as manufacturers and as the people who are going to implement the product, it's then our way to come back and say, look, we have to think about changing this now because either it's not possible or it's very expensive. But don't limit yourself at all. You've got to shoot for the stars first of all.
Thank you. We have a question from George Moon here, asking what research has been done into alternative materials for using fan blades.
I don't know off the top of my head that answer to that question, sorry.
Me neither. I think, and even more in this solar market, which has been only reselling standard fans, there's actually no innovation. As I said before, there's actually no one pursuing innovation or true innovation in this cooling market.
Thank you. Another question that's coming from Silvia Obetti. So most of the solar cells have quite poor efficiency in converting sun radiation to electricity, yet activities like cooling or cooking require high power capacity. The question is, how shall we overcome these challenges and this discrepancy between poor efficiency of solar cells and the high need of cooling and cooking?
Again, the we're not here to reinvent the solar cell, so we're not gonna be changing that the efficiency of the solar cell ourselves. But that's not, I don't think, the issue for this challenge. The issue for the challenge is to reduce as much as possible the power consumption of your design. And for a fan, I think we can get the power consumption quite low. If you look at other types of cooling, like air conditioning, then yes, the problem around that is it still consumes a lot of power. But I think the key to it is to make the most power efficient design you can for the fan, and then allow the solar companies to put together the panel, the battery, and everything to power that. At the moment, we find that we can comfortably run a DC fan that's not well designed, that's not been efficiently thought out from a 30-watt solar system quite easily, including some lights, including charging a cell phone, and in fact, even including watching a small television. And you can get 5 to 6, up to 8 hours of use a day from the battery that's powered by that solar cell. With the input of this design challenge, hopefully we can reduce that even further and not only give longer run times, but even potentially run more than one fan from a system.
Great, thank you. Next question. Could you tell us more about what's happening in the field regarding e-waste? So you mentioned it, but could you tell us more on what manufacturers are looking at to reduce the waste and maybe just avoid having waste in the first place?
Yeah, well, actually, all these companies which build solar home systems, we are in the sustainable movement. So we care about the environment, we care about other people, and if we see a lot of e-waste being generated, of course, it's our responsibility to deal with that in the first place. So far, well, we actually have our products in Tanzania, and it's being really hard to find companies which can properly recycle or process these wastes. So what happens at the moment, and also because, as I said before, companies tend to put the batteries inside the enclosure, then the battery fails sooner than expected, and you have to throw the whole system or the whole unit. So we are generating a lot of e-waste, and there's lack of companies which can deal with this. That's why, from my point of view, if we design in a proper way and we think in advance of this problem, then we will help a lot to mitigate this issue. By how? Well, actually, I think that having, let's say, 2 to 3 components to make the enclosure, and those components are all the same material, let's say ABS or all metal or just 2 different ones, then it gets much easier for companies to recycle and deal with e-waste. But it's a challenge that we all have at the moment, and everyone at the sector, I think, acknowledges.
Yeah, I mean, I echo what Ulysses said. I think with a fan, there's the potential to design it in such a way that the 1 or 2 component parts that can possibly break down are easily to change. Hence, you shouldn't be throwing away the whole body and the casing for recycling. It should last for many, many, many years. What we find with the solar home systems, as Ulysses said, is that 95% of any issue is going to come from the battery. And so it's just that one component that we have to be able to think about how we can access it, change it for our customers, and so on. And if the LED, the panel, the casing has got a lifetime of, many, 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 many years.
Can I add something? And this is a key point when you're going to design for this sector, is actually if you're going to go cheap components or expensive components while keeping your price tag. Why? Because at the moment we see a lot of Asian products. We actually have low quality components, but you are deploying your products in a field where there's people using it in a really harsh way. Environment has really hard conditions. There's a lot of dust, moisture. You never know if the product is going to be dropped or used by kids. So from our approach, we tend to do really reliable components, long-lasting, and we think that even we can use them or refurbish them. So going for cheap components or cheap enclosures, let's say, probably in the long run, it's going to be much more expensive.
Yeah, I completely agree with that.
Thank you very much.
We have to give it a warranty. One of the other key things, remember, is we have to warranty the product. So as a manufacturer and as a distributor, you have to warranty it, maybe for 2 years, but maybe for 5 years, potentially for longer now. So we have to be assured that the design can work with those type of warranties as well, yeah?
Yeah, that's a key aspect when you're talking about pay-as-you-go products, because as long as you have this payback period, you are willing a lot of satisfaction from your customers. So if you need to keep them happy and the product is failing, you're gonna replace it, obviously. But if replacing means replacing the whole unit or the whole system, then it's a huge, massive cost for distributors. They really need to change components or fix them. And yeah, that's the way actually we try to save money.
Thank you very much. Very cool answers. Ulysses, you just mentioned it, and that's a great transition towards the next question that comes from the audience, which is what are the technical challenges faced by fans operating in different conditions across geographical regions, so such as humid heat versus dry heat, for example? So could you detail a bit more the challenges that this induces?
Well, when it comes to my design process, my challenge is, I would call it extreme design. I normally don't take into account several geographic regions, but I take into account the most harsh conditions. And that's my starting point to then say, okay, we need to have this type of feature, which will be humidity proof, waterproof, or actually would help us to dissipate better heat, you know, because your product may be plugged next to a wall, which is under the sunshine of 43 degrees. And yeah, that could alter the efficiency really, really bad.
Yeah, I mean, from our experience so far, the biggest killer to fans has been dust and water. Particularly, as you just mentioned, people use them a lot outside. It gets left outside, it gets humid or it rains, water ingress is an issue, but the bigger problem has always been dust so far. Dust gets into the motor or into the bearings around the blade and then causes problems.
Mosquitoes too, they're everywhere.
Thank you both. So I think we're running out of questions, but we're also running out of time, so it's perfect. I want to thank you both for your participation today, for these very insightful presentations and answers. Do you have anything to add before I close the webinar?
No, thank you for giving us the opportunity. It was excellent.
Well, I would like to encourage all participants to also check all the other projects that Efficiency for Access is doing, because they're actually leading some projects in the industry, such as Open PayGo Link, which will enable to have pay-as-you-go appliances. So not only the charge controller, but actually anything could be pay-as-you-go. So yeah, I encourage them to visit the website and check all the great projects that are coming from Efficiency for Access. And thank you, everyone.
Thank you very much. To all the attendees, and I see that we just got a new question, but I suggest you contact directly the email address from Engineers Without Borders or our participants that shared the email addresses before. We'll see you all again tomorrow, same time, for a webinar focused on agriculture with two of our industry partners, other industry partners. Thanks to all of you for attending, and we are looking forward to see the fans you will design through this competition. Thank you.
Thank you. Bye-bye.
Bye.
Bye, thanks.
Bye-bye.